So now we're ready to talk about variable scope, which is an important coding concept in general. First, when I say scope, I'm referring back to that concept of containment that we started out with. Remember when I hauled out all those boxes to hopefully illustrate this inner and outer containment structure? That's what I'm referring to when I'm talking about scope. Whatever is in each container is within the scope of that container, right? It's pretty simple to understand. When you have, jelly beans in a jar, those jelly beans are immediately within the scope of that jar, right? The jelly beans belong within the scope of that jelly bean jar, you could say, unless there's a way that we can reach in and take them out of that scope and say, put it into our scope, which would be the room we're standing in, right? Our container at that moment. Okay, so that's what I mean by scope. So when we look at our containment structure, we've been writing most of our code in our method containers. But so far, most of what we've written belongs in that scope. But actually, perhaps without completely realizing it, we have created yet another containment scope in the last few videos when we touched upon conditionals. Remember how I mentioned that those curly braces can be seen as the walls of your container? Well, creating an if statement introduced another containment scope within our method container. So just like with the jelly beans in a jar, the code within that statement, that if statement, for example, belongs to that scope. It most immediately belongs to that scope, and the outer scope would be the method container. All right. So let me write some code, and you can try to guess at the output and why it may or may not work. All right. So let's actually create a new script for this. Call it scope test, or just scope. And then we'll, as usual, attach it to our test game object so we can see its output. Click and drag it there. So just as before, tidying up our script, our class, and making sure that it's as simple as possible for what we need to do. So right now, let me just create a method, call it scope test, and we'll write in this code, if conditional. Now we're going to create another containment structure. Type this in, string inside var, and we'll assign a string to that. Outside of this scope. And then we will put in the debug log that output for inside var. All right, and here, in order to just make it evaluate true, we'll just type in true. All right, that's just useful for testing purposes. Don't let that confuse you. We'll just make it true and it will absolutely evaluate that if statement. All right, so already we see a red squiggly line, so that'll probably give you a hint as to what to expect with this output. So here we have a variable which is first declared in the conditional code block, making it immediately belonging to that scope, the scope of the conditional code block. All right, so when we try to reference it outside of that scope, it simply doesn't work. Here we would have to put the debug log output inside of that conditional block in order for that to be able to reference that variable and get that output. Or else we would have to first declare the variable in the outer scope, the same scope that the debug log is in. All right, that's another option. So let's do that and demonstrate how that would look. Let's type in string outside var, and I'll rename that to outside var, and type in accessible to inner scope. Outside var, and let's see if this works. Build it. Excuse me. I already declared it as a string and I don't have to do it again. So remove the type in the conditional. And there you go, it builds fine, build succeeded. So as you can see here, the rule of thumb is that the inner scopes can access elements that are first declared outside of its scope, but the reverse is not possible. So in other words, inner containers can reach out and grab elements from outer containers, but outer containers can't reach in and grab elements from inner containers. So real simple rule of thumb to generally keep in mind. Here's another example with another level of containment, just to make this explicitly clear what we're doing here. Start from scratch. So type in string outside var, right? So we're declaring that variable. And if true, creating a conditional block, outside var equals accessible to inner scope. All right. Now we're going to create yet another containment structure, a nested if, and we'll type in, so we'll reference that variable and we'll assign it a new string, accessible to inner scope. Right? It is accessible to this inner scope. And then in this conditional block, this inner scope, we'll declare a new variable called inside var, and we'll say it's inaccessible to outer scope, because it is, as we will see. So outside of that scope, we'll try to output it, the inside var variable, to a debug log. All right, and tell us this doesn't even work, which again is a hint that this is not going to work. Right? Try to build it. Doesn't work. See, the name inside var does not exist in the current context. Line 23. Right? And just to demonstrate that we can output the outside variable, outside var. Try building again. All right, no new errors, right? Because outside var is, the debug log is in the same scope of which the outside var is declared. Right, so in the end, this is important because you will want to determine if and when variables are declared first. If they are needed in a broader scope, then make sure you first declare it from the outermost scope it needs to be able to be referenced from, right? So normally you would declare your variables with the broadest scope in mind and only declare variables within narrower scopes if they are needed only temporarily for a specific task, for example. Now this brings us back to our class container, which is our outermost container that we see right now. Because you may have noticed that we created our method definitions at the class level. The scope being directly within the class container are where our methods are being defined, right? And as we've seen, one method definition can reach out from within its scope and call a method that belongs to the outer scope. Let me just delete this. Actually, no, we'll just leave that and I will go back to conditionals, for example. See, the start method definition is able to call the state handler. It's able to kind of, reach to its containment level, which is the class level, and reference the other methods at the same scope at the class level. This is the same behavior that we just described with variables. So the logical question is, can we declare variables at the class level to get the same kind of functionality so that all of the methods can, for example, reach out and reference those variables declared outside of the method scope? Well, the answer is yes, absolutely. And actually, you maybe remember back in our first few videos, we start off by doing just that. And it's actually crucial that this is the case, that I will explain in a moment. So this whole time, we looked at method definitions as the members of our classes, right? Well, when you have a variable that is a member of your class, within the immediate scope of the class, in other words, that variable is a special kind of variable called a field. Now, it still functions under the same rules that we've seen with other variables thus far, so no need to wring your hands and worry about getting fields straight with, is this a field, is it a variable? It doesn't really matter. They're all the same in terms of how they work. It's just the scope that they are declared in that's the difference, right? So when you have a variable at the class level, it's called a field. Otherwise, if it's declared first at the method level, it's just an ordinary variable, right? So as we will soon see, this is actually a big difference in how we can make use of those variables, again, in a broader scope. So for now, just know that when you have a field, a class level, class scope variable, it can be referenced by the methods within that class. Let's see very quickly how this can be useful to us. All right, let's forget about this class here. And let's create a new class, right? So let's go back to Unity, create C# script, and we will call this, call it field test, all right? We'll just tidy it up and get it to our liking first. And then let's attach it, be sure to attach it to our game object. All right, we're just going to get an error with this code, so let's comment that out first before we move forward. All right. And with field tests, let's make sure to attach that to our test game object as we did before. Turning off scope and putting field test there. All right. And here, let's create our field, our class level variable, call it message hello, kind of harkening back to our hello world beginning. So that's a field, again, because it's immediately within the scope of the class. It's a class level variable, right? And in start, well, let's not write anything just yet. Let's actually create a custom method that will want to output something and write this message equals message plus world. And here in start, type in debug log message, right? And then, well, let's just run that right now so you can see that this is working. There you go. Hello is our output. Nothing too fancy and interesting yet. But now let's do this. Let's call our method, which itself references our message string within it. So just call the method like that. Then we will, so we'll run that method. And now we will output message again after that method runs. And there we go. We get hello first and then hello world. So the contents of message, which say hello, stay alive in between the method calls. And to make this obvious, I'll just run the method again and output to the debug log once again, so you can see that the contents are kept between method calls. There you go. See, it retains hello world from our first method call, and in the second, after the second method call, it postfixes another world to our variable message, our field variable message. You see here that the reference for message stays alive between method calls. Normally, our variables that are first declared within our methods are only alive until that method completes executing. The method then resets at the end of the execution, and all of the variables originally declared in it do so as well. right? The compiler essentially removes those variables from memory space and starts over again if you run the method again, right? So variables declared in methods are kind of like Groundhog Day, repeating the same thing every time. So you can see how declaring variables at the class level, fields, can be very useful to keeping certain values alive between method calls. This is extremely useful for a lot of reasons. One of the most obvious reasons being that for game related to game design is, imagine you have a field for your character, let's say his health meter, which could be an int. Let's say you want to run a method on it that deals out damage depending on certain circumstances, right? Well, if you declare the character's variable holding his health points within that method that deals the damage, his health will always be reset whenever you deal damage. But that's not how games work. You want to just subtract from those health points without caring how much those points are. Let me quickly illustrate how this could be useful. So let's create a new script called damage test, and let's create first a field. Let's first create a field that holds our health points. So let's create an int, call it health points, and let's arbitrarily assign 100 to it. And let's make a custom method that deals damage. So call it deal damage, makes sense. And let's simply take those health points and minus equal. Remember, minus equals just is the same thing as saying health points equals health points minus whatever the value's on the right, and we'll just say 5 to make things simple. And here we will actually call deal damage. And so we can see the result. We'll simply output to the debug log as usual our simulated health points for our mock video game example. And I'll save that. And in Unity, I don't believe I attached it, so let's attach it first and disable field test. Go to our console and see what we get as an output. 95, right? So if we do this again, if we deal damage again, we'll get the functionality we want, where it just takes off 5 points every single time we deal damage, and we don't have to worry about what value our health points are at. See, if we made the variable first declared not as a field but in health point, deal damage, just move it simply to our deal damage method, right? And I'm just going to comment that out so that we're simulating not having a field anymore. All right, already we're getting these squiggly lines because we're not going to be able to reference health points. Remember back to our demonstration in our previous video. So what I'll do is I'll just simply put the debug log into our deal damage method so that it's at least correctly scoped. And I didn't remember to declare that as an int, which it of course is. And now I'll see what happens. So we're calling deal damage, the method deal damage, twice. Let's see what the output is. $95 and $95. See? That's because health points in this context is no longer a field. It doesn't stay alive in between these method calls. After this method is called, the first one, it resets, and we call the method again, and it's the same health points resets, and it's the same value it was before we called deal damage the first time, right? Groundhog Day, as I mentioned. So I'm just going to change this back to how it should be. Just going to undo all my changes here. And there we go. So it hopefully will make a lot of sense when making our games when and if to decide on using fields versus locally scoped method variables. If that variable represents some kind of essential value in the context of that class, something that's, you could say, important to the state of that class, that you expect the update engine will want to keep alive in between update calls, for example, that would be a good candidate for a field, right? But besides all this, there's actually another reason to create fields, and that is potentially to allow them to be accessible to other classes. It may not seem like it, but this directly leads us into one of the most exciting and interesting aspects of C#, and that's object-oriented programming. A big key to understanding Unity and C# is unpacking this object-oriented model. It's really fascinating stuff, and we'll now be setting out to do exactly that. Really interesting stuff right ahead. Hope to see you in the next few videos.